These farmers are harvesting coffee cherries, small round berries that contain coffee beans. And to produce just 1 pound of coffee beans, 1,500 of these coffee cherries will have to be harvested. But that's just the start. Coffee making is complex and labor-intensive, and to understand just how complex, we visited a factory of one of the leading coffee brands in the world, Nescafé. It all begins at farms like this in Brazil and Vietnam, one of the 2 main coffee-supplying regions of the world. The coffee cherries start out as clusters of small, fragrant white flowers resembling jasmine. Once pollination occurs, the flowers wither and fall off, giving way to small green berries. These berries take 6 to 11 months to take on a beautiful red color, indicating that they're ready to harvest. In large-scale coffee farms, mechanized harvesters like this are employed to increase efficiency. The amount of cherries it would have taken farmers days to harvest is collected by this harvester in just a bunch of hours. It employs these vibrating fingers to gently dislodge coffee cherries from the plants. These fingers are durable and flexible, but gentle enough not to damage the trees. The machine spends up to 3 seconds passing over each tree, gently shaking it so that only the mature cherries fall off. This is because mature cherries are softer and detach more easily from the coffee tree's branches or peduncles. These cherries flow over a series of spring-loaded fish plates into a bucket elevator, which transfers them to a holding tank on the harvester to await collection. There is one crucial problem here though. When the whole tree is picked up at once, ripe and unripe cherries are lumped together despite the precautions. For this reason, farmers may still handpick cherries selectively, focusing only on the ripest fruit for specialty coffee. To get rid of the unripe cherries that made it into the batch at the time of harvesting, many plantations employ water flotation sorting. This technique takes advantage of the fact that ripe cherries are denser due to their higher sugar and moisture content, causing them to sink in water. On the other hand, unripe cherries, which are lighter and often contain air pockets, float to the surface. Flotation tanks or channels are used for this process, where the cherries are submerged in water and automated paddles or suction systems skim off the floaters. The sinkers, which are ripe cherries, continue to the next stage of processing. This method is simple, cost-effective, and also helps remove overripe or defective cherries. Once separated, this final batch of only ripe coffee cherries is ready to be processed to extract the beans. They are transferred to the wet mill where they will undergo a process called wet processing. In wet processing, cherries are fed into pulping machines like this one, which removes the outer skin. The pulping machine uses a rotating drum with calibrated perforations to crush the cherries while allowing the beans to pass through intact. The beans that come out are covered with a slimy layer called mucilage, which must be removed. For this purpose, the beans are placed in fermentation tanks where they rest for about 14 to 16 hours. Fermentation breaks down the mucilage so that it can be washed away. After fermentation, the coffee beans are pushed through channels like this, cleaning off the seeds. This is also where premium coffee beans are separated from lesser quality beans. You see, the denser beans sink in the water channels, whereas the less dense beans float to the surface. These aren't wasted though, as they still sell, but for a much lesser price than the premium beans. After the premium beans have been separated, they are directed towards soaking tanks where any remaining mucilage is drained. Here, the workers fill the tanks with water and agitate the coffee with a wooden tool. See how the water becomes murky as it starts to fill with the leftover mucilage? This process is repeated several times to make sure the coffee beans squeaky clean. Once the seed is free, the coffee flows out of the tanks and onto drying tables. Here's where the workers spread it evenly on drying beds like these. These beds allow for airflow around the beans from all sides, promoting even drying and preventing mold formation. Workers frequently turn the beans with wooden rakes to ensure uniform drying and to prevent clumping or fermentation. The practice has become a norm not only for commodity coffee, but for specialty coffee as well, as it minimizes contamination from the ground and improves quality. Throughout the drying process, moisture levels are carefully monitored using moisture meters. The goal is to bring down the moisture levels of the coffee beans to about 11 to 12% to prevent mold and spoilage. This will take about 1 to 2 weeks depending on the weather conditions. Drying can be very tricky, and workers take extra precautions to ensure that the beans are dried slowly and evenly. Rapid drying can cause cracking, while uneven drying can result in spoilage or off flavors. After the optimum moisture levels have been ensured, the coffee beans continue their processing journey into hulling machines like this one. Hulling is a crucial process. Its purpose? To remove the protective layer surrounding the coffee bean called the parchment layer. The hulling machine's process starts with a feeding mechanism, where the dried coffee is loaded into a hopper. Inside the machine, the beans pass through a dehulling chamber where friction or abrasion removes the outer layers. Afterward, a separation system ensures that the beans are cleaned of debris and fragments. Modern hulling machines often include features like adjustable pressure and speed to accommodate different bean sizes and moisture levels. Some even integrate grading systems that sort beans by size during the process, improving efficiency. Once the hulling is complete, the beans are known as green coffee. These hulled beans are inspected to ensure all outer layers have been removed. This is because any remaining husk or parchment could affect the roasting process and flavor of the coffee. Uniformly hulled beans are essential for consistent roasting, which ultimately determines the coffee's flavor profile. The hulled beans are stored in 60-kilogram jute bags, labeled with origin and grade details before they're shipped off to Nescafé factories around the world. As the trucks carrying the coffee bean bags arrive at the factory, they're unloaded with robotic arms into giant hoppers that drop the coffee beans into sifters like these. These machines consist of multiple layers of perforated sieves, each with holes of a specific diameter. When the beans are poured into the machine, they are vibrated across the screens. Larger beans remain on the uppermost sieve, while smaller beans fall through to lower levels. This separation creates uniform groups of beans, classified by size. For example, beans are often graded with sizes ranging from 14 to 20 millimeters. If you were to smell the coffee beans at this point, they'd smell like plant seeds. As for the taste, let's just say that it wouldn't taste anything like coffee. All that transformation happens inside a roasting machine like this one. Inside these machines, roasting happens in a total of 4 steps. First up is drying. Coffee beans with a natural humidity of around 10% must be carefully dried before roasting begins. The duration of this step depends on the roaster being used, but the beans should reach a temperature of approximately 160 degrees Celsius by the end of the process. Precision is crucial during this phase, as overheating or heating too quickly can scorch the beans. This stage also stores energy within the beans, which will be released during the next exothermic stage. As the beans dry, their grassy aroma begins to change, giving way to scents reminiscent of hay or toast. This shift signals the transformation of aroma precursors into aroma compounds. During the subsequent browning stage, the Maillard reaction, a pivotal chemical process, takes place. This reaction occurs when the beans have absorbed sufficient heat, causing amino acids and sugars to interact. This not only deepens the beans' color, but also develops their unique and distinctive aroma profile. At the end of the browning stage, the first notable milestone in roasting, known as the first crack, occurs. During this moment, the coffee beans expand, moisture evaporates, and steam builds up inside. The resulting pressure causes the beans to crack open, producing an audible sound similar to popcorn popping. The development stage follows, marked by an exothermic reaction. This is where the beans' stored energy is released, leading to further cracking and the creation of complex aroma compounds. The duration of this phase is determined by the desired roast profile. If a darker roast is sought, a second crack may occur as the beans continue to expand and oils are released to the surface. However, care must be taken not to over-roast, as going too far beyond the second crack can result in a baked, doughy flavor, diminishing the coffee's quality. Once the desired roast has been achieved, the coffee beans need to be transferred to a cooler tray so that they can be cooled quickly. If they are not cooled quickly, the heat given off by the beans can cause them to continue to cook even after they've finished roasting, resulting in burnt and charred beans. The roasted beans are ready to be ground into a fine powder. This powder is then put through an extraction process. In large-scale production, coffee extraction is typically done in large brewing tanks or extractors where ground coffee beans are steeped in hot water. Water is pumped into the tank at specific temperatures, usually between 85 degrees Celsius to 95 degrees Celsius, where it interacts with the coffee grounds to extract soluble compounds, such as caffeine, sugars, and flavor oils, into the water. The goal is to extract the coffee's soluble solids without over-extracting bitter compounds. This extraction process can last anywhere from 30 minutes to several hours, depending on the scale and type of equipment used. To make instant coffee, Nescafé Original uses a spray drying method. In this method, the concentrated coffee is sprayed into a hot, high-pressure chamber where the liquid droplets are rapidly dried by hot air around 200 to 300 degrees Celsius. As the droplets hit the hot air, they quickly evaporate, leaving behind small coffee particles. Nescafé Gold, however, uses a freeze-drying method. In this process, the concentrated coffee is first frozen at very low temperatures, often at -40 degrees Celsius or lower. The frozen coffee is then placed in a vacuum chamber where the temperature is gradually increased. As the temperature rises, the ice in the coffee sublimates, meaning it turns directly from solid to gas, leaving behind the coffee solids. The result is a light granular coffee that retains much of the original flavor profile and aroma. The final step in the process is packaging. Nescafé's instant coffee is packaged in various forms, including jars, sachets, or bulk containers. Packaging is done using automated systems that fill, seal, and label the containers quickly and efficiently. Airtight packaging is crucial to preserve the freshness and flavor of the instant coffee, as exposure to air can cause the coffee to lose its potency and aroma over time. Some systems include nitrogen flushing in the packaging process, where nitrogen gas is used to replace the air inside the containers, further preserving the coffee's quality. For retail-ready products, the coffee is often portioned into individual servings, such as single-serve packets or cups. These packets are sealed tightly to maintain freshness until they're ready for use by the consumer. Coffee making may sound labor-intensive, but that too has its advantages. It provides livelihood to many people around the globe. Just Nescafé has more than 8,000 employees globally working in 25 factories that produce instant coffee. It also holds a significant share of the global coffee market. In 2021, Nestlé's retail coffee market share was 22%, making it the leading coffee company worldwide. In the United Kingdom, Nescafé commands a dominant position in the instant coffee segment, holding a 49% market share. But this dominance didn't come about without some shrewd decision-making. You see, in the 1930s, Brazil found itself with a massive coffee surplus. To help manage this surplus, Nestlé collaborated with the Brazilian government, aiming to boost coffee consumption and introduce a new way of enjoying it worldwide. But how would they go about doing this? In comes Max Morgenthaler, a brilliant chemist working for Nestlé. Morgenthaler and his team developed a soluble powder that could be brewed in an instant, allowing coffee lovers to simply add hot water and enjoy a cup of coffee in seconds. The result? Nescafé became a household name and changed the way people experienced coffee forever.